All right, all the PBS has washed through. After multiple washes, we've got as much of the extra fluorescence quencher, autofluorescence quencher out of the way. So notice some of the things that I've got out here. A metal tray so that I can balance the slides without having them stick to the table. Some clear nail polish. We're going to use this clear nail polish as glue to glue our cover slips. I've got a whole box of a special kind of cover slip that works well with the confocal microscope. Here's our cover slips. They just look like microscope slides, except they are much thinner than a microscope slide. So we're going to use one of these on each of our slides. So we've got a glass slide covered by a glass microscope cover slip. However, notice that in cover slipping, we want to add a couple drops of Prolong with Dappy. This is our Prolong Gold Anti-Fade Reagent with Dappy. This one hasn't been opened yet, so we're going to use up some of this that has already been used. Prolong Gold Anti-Fade Reagent with Dappy. Dappy is a blue dye. It absorbs UV light and glows blue. And what does it bind to? The nucleus, to DNA. So we're going to light up our nucleus blue on every cell on both these slides. We already have lit up their membranes red with Alexan 594 bound to wheat germ agglutinin. And hopefully on this slide only, we'll have green where our antibody of choice is binding to our protein that we are interested in studying. So the steps that we need to do now are we need to add some of this liquid to our slide, and we need to then cover slip using the... Let's start with our negative control slide. If I do anything bad or mess it up or don't remember how to cover slip for some reason, it's better to mess up this slide than the one that actually has the primary antibody on it. Remember, primary antibodies are quite expensive. Now is the first time since we started the procedure, so from 2 days, now that since we first put this cover plate on, that we are going to remove the cover plate. So what I want to do is gently lift this up and have hopefully as few of the sections as possible stick here. Oh, we lost a couple sections on the cover plate. But see how almost all of our sections are still here on our microscope slide. Any extra PBS, I'm happy to have that drip off onto a paper towel to dry it. Because now I'm going to add this liquid. I don't want to add too much, so instead of using a disposable transfer pipette, I'm going to go ahead and just grab a couple drops this way. So I've got some liquid here, and I want to add a few drops. This liquid can spread throughout the microscope, across the microscope slide, and I'm going to press it into place using this very small cover slip. Now I've got some forceps. These forceps are a little bent at one end so that I can hold this, and my fat fingers can be way out of the way so that I can slowly let this down to cover my tissue. Now I'm going to use the corner of the glass cover slip to pop any bubbles that I see here first, before I then start to press my cover slip down into the liquid. Now my goal here is I don't want air bubbles. Air bubbles will be visible under the microscope. What I do want is a clear layer of liquid. Oh, you see I dropped it? It fell out there. So I got up to about here with no air bubbles, and then accidentally it slipped out the end. So now I have a cover slip, lots of liquid under there, and I'm going to dab off some of that extra liquid. Now remember, it was only a couple drops I put there, but a drop is about 50 microliters, and remember, in between the cover plate and my microscope slide, I only needed 100 microliters, so certainly 100 microliters is enough to cover where my cover slip is. So I'm going to angle this a few different angles for you. Hopefully you can see. I'll maybe also put it on a black background if that helps. I have a couple air bubbles. I can see them right here. There's a big air bubble right there and right there. but there's a tissue section off to the side of it. My air bubbles aren't covering my tissue section. So I think this is good enough that I will be able to see. I see another air bubble here, and a tiny one up here and here. So it wasn't perfect. I dropped the cover slip a little bit early, but most of the liquid is evenly distributed over my tissue sections. So the next thing I'm going to do is I'm going to balance this on this metal tray. And while it's balancing there, what I'm going to do is I'm going to seal the cover slip, sorry, these are cover plates, right? Cover slip into place on my microscope slide. This is just normal, clear nail polish that you would buy at any grocery store or beauty salon, okay? And I want to get a big drip of this stuff, and I want to paint the edges. What I am doing is I am sealing this so that the liquid, the dappy that is on the inside, cannot get out. I also don't want my slide to be able to move. My cover slip should never move from this position. If it does, it will move the sections of tissue around. So I am using this as a liberal layer of glue around the outside to make sure that there is an airtight covering all the way around, and that my microscope cover slip will never move again. Now, although I have a teenage daughter who is in high school, who likes to paint her nails, I absolutely hate the smell of nail polish. Oh my gosh, this is awful. This is the worst part of lab work, okay? So I can't wait to get this into the hood, where I can let that dry overnight with our hood taking the fumes, those toxic fumes, out of the building. Whew! Got rid of it. Now I happen to have another metal tray with me, so I can do our other slide as well. The reason I like to do it on these metal slides is they have these knobs that stick up. Notice how liberal I was with how much nail polish I was putting. If I put that much nail polish and then put it down on a flat surface, the nail polish would be dripping off the side, and we would glue our microscope slide to the table or to the metal. So I like to have these lifted places where I can easily then add the add my nail polish without worrying about that. So I'm going to gently remove the cover plate, hoping to dislodge as few of the tissue sections as possible. You get a quick close-up of this. Look at these bottom two tissue sections. Oh no! We've done so much washing. Even though we baked these in the hybridization oven, some of the tissue still came loose. If we had been doing this experiment with you for real, I would have used the more expensive slides, which were the Super Frost Plus slides, which have positive charges on them that help hold the tissue down. So this tissue would not be floating away. We're unfortunately going to lose that tissue. We still have many sections to look at, but these sections don't appear to be in wonderful condition. In other words, some of them seem to have lost some of their tissue sections. This is why you would use better slides. We could do more slides instead of just the 2 that I did for this demo. And then we would have many more tissue sections to look at as we do this final step of cover slipping with dappy mounting medium anti-fade reagent. The anti-fade is called that because when light shines on fluorescent things, they get dimmer and dimmer over time. This anti-fade reagent counteracts that and makes it so much harder for the liquid to actually fade over time. Okay, so let's see, I think I want to do it this way. I'll grab another cover slip. I'll get it in my fancy microscope slide holder and slowly try to get some liquid there. There we go. See the liquid coming up from this bottom corner right here? It's moving up to here, moving up to here, Now there's a big glob that I just got of the anti-fade reagent. So I want to move slowly from here. Oh, I'm doing a much better job this time. Trying to not get any air bubbles. The liquid is now mixing. And from here, I sort of have to let go. I'm sort of out of room to lower it anymore. So I sort of just have to drop it on and hope that the liquid can spread without causing too many air bubbles all the way up to the top here. So this is completely wet underneath now in all directions. We've got our tissue on the slide. Some of those sections we won't be able to see because they're going to be too close to the edge. So when you use the cryostat and put tissue sections on a piece of microscope slide, make sure to try to put as many of them as close to the center as possible. Finally, we'll do the final step of nail polish this into place. Phew! Run away! Oh, this is awful!
Smell it from here.
Of course you can. Oh my gosh, this is terrible. Good thing it's late evening and no other students are here, so we won't be scaring away any other people. Woo! Nail polish, the worst. Okay, I'm going to add this slide to my rack over here. Make sure that it's balanced so that the nail polish won't dry it to the metal plate. And now what I'm going to do is I'm going to take another metal plate and put it upside down on top and turn all the lights off so that the fluorescent molecules aren't being hit by light all day long while we let this dry. You must wait at least overnight, at least 16 hours for that nail polish to dry, because if you put that onto a microscope slide and the nail polish is still wet, the nail polish will get onto the objective lens of the microscope and completely ruin that $5,000 microscope lens by getting nail polish on it that you can't get back off. So we need that to dry well. So I'll just grab another couple things to cover that up with so it'll be in the dark. It'll dry here in the hood so I don't have to smell it. Whew! And we're done for the day.